Welcome to Lecture Online. Here we're going to deal with what we call the conjugate of a matrix, or more properly said, the complex conjugate of a matrix. And the rule says that if you take the determinant of the complex conjugate of a matrix, that should equal to the complex conjugate of the determinant of the matrix. Wow, that's a mouthful. But here we have the matrix. Notice that the elements do include complex numbers. And here's the complex conjugate of that matrix, which means that for every negative I number, like negative 3i becomes a positive 3i, the plus 2i becomes a negative 2i, and the positive 4i becomes the negative 4i. What we're going to do now is we're going to take the matrix of the conjugate, or I shouldn't say the matrix, but the determinant of the conjugate of matrix A. Let's do that and see what we get. We take the complex conjugate of matrix A, we take the determinant of that, which is equal to the determinant of the following: 2 plus 3i, minus 1 minus 2i, minus 4i, and 5. The rules are exactly the same. When we take the determinant, we multiply these diagonals and then subtract the product of those two diagonals, or those two diagonals. So we get the product of 2 plus 3i multiplied times 5 minus 1 minus 2i multiplied times a minus 4i. Let's simplify that and see what we get. This is equal to 10 plus 15i minus 1 times a minus 4i is a plus 4i, and a minus 2i minus 4i is a positive 8i squared. Of course, we should remember that I squared is a negative 1. So this can be written as 10 plus 15i minus 4i times negative 8. And then we can apply the negative sign and switch orders here. So this can now be written as 10 plus 15i. That would be minus times the minus, that would be plus 8 minus 4i. And then if we combine like terms, you can see then that this is equal to 10 plus 8, or 18, and plus 15i minus 4i, which is plus 11i. And that is the determinant of the complex conjugate of matrix A. Now let's go ahead and find the matrix A, or I should say the determinant of matrix A, and then take the complex conjugate of that. So first we take the matrix A, find the determinant, which is equal to, we take the original matrix, 2 minus 3i, minus 1 plus 2i, positive 4i, and 5. We do the exact same thing. We multiply the diagonals, which gives us 5 times 2 minus 3i, and then subtract from that the product of those two, which would be 4i times minus 1 plus 2i equals. Simplifying that, that gives us 10 minus 15i, and this gives us minus 4i times a minus 4, that's minus 4i, and 4i times plus 2i is plus 8i squared. Simplifying that a little bit more, this gives us 10 minus 15i, minus times a minus gives us a plus 4i, and then of course I squared is a negative 1, times 8 is negative 8, times a minus is plus 8. And if we then combine like terms, this simplifies to, that would be 10 plus 8, which is 18. In this case, it will be minus 15i plus 4i, that's minus 11i. Notice that here we got 18 plus 11i, and here we got 18 minus 11i. But then according to this, after we take the determinant of matrix A, we need to find the complex conjugate of that, which means that if we now take the complex conjugate of this, this is simply equal to this, but with the negative change to a positive, so this becomes 18 plus 11i, and then you can see that this That's not written quite right. I should go like this. This is for the whole thing, right? So this is equal to 18 plus 11i, and you can see that this is also equal to 18 plus 11i, which shows then that if you take the determinant of the complex conjugate of a matrix, that is equal to the complex conjugate of the determinant of that same matrix. And this is how we know that that works.